Hey guys, I'm going to try this YouTube thing. We'll go back and look at that 9.3 apply worksheet that you should have on the cycles of the copper reactions. Again, you should be working on your test also, your chapter 9 test. Some of you got that to me, great. Again, use this to help you review, help you on the test. So we had 3 reactions that they set you up with. The first reaction says we're going to take copper nitrate and she's going to add sodium hydroxide to it. So you needed to come up with the formula for copper nitrate. The other thing is, hopefully you notice, is that they didn't name the compound right. It should have been copper 2 nitrate. Because when they gave you the formula, notice that, again, with your ion charts, the nitrate is a -1 polyatomic. So we have 2 of those. It has to be a copper 2, so it's actually copper 2 nitrate. That was reacted with sodium hydroxide, okay, NaOH. And it says write the unbalanced equation. So they gave you that much. You then had to look at reaction 2 to give you a hint. It says, she then removed the copper-containing compound produced in reaction 1 and added it to a beaker. So that means it must have came out as a solid. So what we have here is a double replacement reaction. And we have copper hydroxide. Okay. And we get sodium nitrate. Now, we have to double check, make sure that those formulas are correct. Hydroxide is a -1 polyatomic. We know that this is copper 2, so we need to make sure that we write the right formula for that one. We double check sodium nitrate. Sodium's a +1, nitrate's a -1. That one's good. Okay, so we write it unbalanced. We just leave it alone. Then we go down to reaction number 2. If we know this came out as a solid, we can put that on there because she removed that. Okay. Everything else on there we're really not sure of because it doesn't tell you. But we also know this one stays in aqueous. Most nitrate compounds are aqueous, but we don't need to worry about that part. On reaction 2, we take our solid, copper hydroxide, copper 2 hydroxide, and she reacts it with sulfuric acid. We know that's aqueous because all acids are aqueous. Okay, and again, we had to write the unbalanced equation. This one here is an acid-base reaction, which is a type of a double replacement reaction, just as the first one was above. So we are going to get copper sulfate. Okay, and one of our other products is always water. Okay, you didn't necessarily get a salt this time. We then go down to reaction number 3. It says she adds a piece of zinc to the solution containing the copper compound. So this is a solution. So we also know that this has to be aqueous from, again, question number 3 tells us something about question number 2. Okay. So she takes the copper-containing solution, okay, and she adds that, or she adds zinc, and whenever we have just a metal, it's just a symbol, and we know it definitely has to be a solid, and this one's aqueous. Okay, and this definitely looks like our equation for a single replacement reaction, and we get zinc sulfate and copper. And copper is coming out as a precipitate, so it comes out as a solid. Okay. So these are your 3 equations. Again, make sure you double check your formulas are right. I know that on the tests that I'm seeing that I've got back, it's your formulas that are getting you in trouble when you go to try to balance them. So always check. We know this is copper 2. We know sulfate is a 2 minus. Zinc is always a 2 plus. Sulfate's a 2 minus. Okay? Now, then you had the rest of the questions. It says number 4, balance each of the equations. So again, we got to follow the first law and make sure that we have the same amount of stuff on both sides. So what's nice is that our polyatomics stay together, so we don't have to split them up. So let's just look and see what we have. Copper 1, one of those. 2 nitrates, only 1 nitrate. We have 1 hydroxide, 2 hydroxides. So to fix this, we need to put in some coefficients. Grab a black pin here. So we need to put a 2 here to balance that. Now we have 2 hydroxides. That makes that happy. But now we have 2 sodiums also. But remember, we need to have 2 nitrates. So I can put a coefficient number 2 right there. We now have the balanced equation for the first reaction. We look at the second one. On this one here, it's a little bit different. Our hydroxide doesn't stay together. We get water and a aqueous solution of copper. So we have to break this one down as we have before. Okay. We take a look at it, and we just initially, let's count what we have on each side. 1 copper, 1 copper. Good. 2 oxygens plus 4 oxygens is 6. Okay. We have 2 hydrogens, 2 hydrogens, 5 oxygens, 5 oxygens. Or sorry, 6 oxygens and 5 oxygens. Can't count myself. So the only thing we need to balance is our water on this side. Again, I have a total of 4 hydrogens and 6 of these oxygens. If I put a 2 here, there's my 4 hydrogens. 4 plus 2 more oxygens is 6 oxygens. We're balanced. Okay. And then the last one, copper sulfate and the zinc. You look at those, and they're already balanced. So even its unbalanced equation is its balanced equation. And then the last thing you had to do on question number 5, what were the types of reactions? I already said that this one was a double replacement. This one here, with our notes, we could say was an acid-base. Or you could also call it a double replacement. Either one would have been great. And this last one down here is a single replacement. So again, I sent the answer sheet to you so you can double check it against that. And again, use those answer sheets that I sent you and work backwards through them, reverse them. Okay? If you have questions, make sure you email me. I'm going to try to set up a Zoom thing on Monday. We'll see how that goes. All right? I'll try to do another one of these if this works out. I'll see what kind of response I get back from my emails. So if this helps a little bit, those of you that are still working on your test, great. Those of you that are doing corrections and stuff that have talked to me, okay, hopefully this helps out too. Thank you.